The last topic that we'll consider here is the idea of a tree. In a network situation or a graphing theory situation, a tree is a graph that contains no circuits. So there's an example of a tree. This one has 1, 2, 3, 4, 5, 6 vertices. So this is a graph of order 6. The size is 1, 2, 3, 4, 5. Size is 5 edges. And you'll notice that in this graph there are no circuits. If you leave a point, there's no way to get back to that point without retracing your steps. And that's the case for any vertex in this graph. Right? That's a tree. If it had a circuit, say I add that edge, this is no longer a tree because now I can leave this point and come back without retracing any steps. So basically a tree has no circuits. Okay? That's what a tree is. Now what we're going to be looking at is a special kind of a tree which is known as a spanning tree. Now a spanning tree is a subset of a bigger graph that provides a path between any pair of vertices in the graph. All right, so a spanning tree, let me give you a graph that's not a tree. Let's see, we'll make this an order 5 graph. We've got 5 vertices, and we'll put some edges in here. Like so. Okay. Let's make it a complete graph. If you remember what a complete graph is, there's a direct edge between any pair of vertices. All right, so there's a complete graph of order 5. Now, if I want to make a spanning tree, what I'm looking for is a subset of this graph, a subset that will connect any pair of vertices with some path. For example, if I were to just take a subset that consists of this edge, this edge, this edge, and this edge, right? Those 4 edges only. What I have is a tree, but not only do I have a tree, but I also have reached out. I like to think about it in terms of reaching out and touching every vertex in the graph. So this would be a tree that spans this graph. These 4 edges represent some subset of the graph, and then all 5 vertices are connected. Right? That's not the only tree that's possible. Take a look at a couple of others. Let's see. That would include this edge, includes this edge, includes this edge, and includes that edge. Right? So those 4 edges, they also form a tree, and they span this graph. All right, so a spanning tree is a subset of some graph that is not a tree that actually spans or reaches out and touches all the vertices in that graph. All right, now later on, what we're going to see when we use Kruskal's algorithm and find the minimum cost spanning tree is trees that have weights on the different edges. And what we're going to try to do is we're going to try to find the one tree out of all possible trees that span a graph or a network that will cost the least amount. Okay, so we'll see that later.